Hello, everybody. Today I'll be covering Module 11, Lesson 11.1 in the 6th grade Go Math textbook. Our essential question for this lesson is how do you write equations and determine whether a number is a solution of an equation? So let's go over some information here. So determine whether values are solutions. Remember, an equation is a mathematical statement that two expressions are equal. An equation may or may not contain variables. For an equation that contains a variable, a solution of the equation is a value of the variable that makes the equation true. So keep in mind, an expression would be like 5 plus 4. Okay. An expression represents a single value, and an equation represents a relationship between two values. So 5 plus 4, the relationship between 5 plus 4 and 9. Okay, in words, this expression here, 5 plus 4, is basically a number plus 4. In the equation, we could say a number plus 4 is 9. So what does that look like algebraically? If you say a number plus 4, we would put in the variable n for a number. And it can be any letter, right? Any letter stands for an unknown number. And the equation would be the same thing, but set equal to 9. Okay. All right, so let's look at our first example. So determine whether the given value is a solution of the equation. So here they're telling us that x equals 6, and we have to determine, is that a solution of the equation or of the expression? I'm sorry. Is 6 a solution of the equation? In other words, if I put 6 in for x, does it make it a true statement? Well, so substitute 6 for x. 6 plus 9, does that equal 15? Well, 6 and 9 is 15. So 15 does equal 15. Therefore, 6 is a solution of x plus 9 equals 15. Another example would be y, some number, divide by 4 equals 32. And we want to know, is 8 a solution? So we're going to substitute 8 for y, and then we're going to divide. 8 divided by 4 is 2. 2 doesn't equal 32. So 8's not a solution of the equation. All right, how about C? So here we have 8 times some number is 72. And we want to substitute 9 for the variable. And so 8 times 9 is 72. 72 does equal 72. So 9 is a solution of 8 times x equals 72. All right, so let's look at page 300 now. So let's do some practice problems. All right, so you determine whether the given value is a solution of the equation. So in number 1, they're telling us they want us to see is 5 a solution for the equation. So we're going to substitute 5 for n. Okay. We're going to add 5 and 6. And 11 does equal 11. So yes, it's a solution. Number 2, some number minus 6 is 24. And they want us to subtract or substitute 18 for y. So 18 minus 6 equals 24. So we're going to subtract 18, take away 6, and that gives us 12. Well, 12 doesn't equal 24, so no, it's not a solution. All right, how about 3? Some number divided by 9 is 4. So we're going to substitute 36 for x. And we'll divide 36 by 9 is 4. And 4 does equal 4. So yes, it is a solution. And finally, 15 times some number equals 100. And they want us to substitute 6 for our unknown number. So we're going to go 15 times 6. And does that equal 100? 15 times 6 Well, that's 90. And 90 doesn't equal 100. So no, it's not a solution. Okay. All right. Let's continue. Writing equations to represent situations. You can represent some real world situations with an equation. Making a model first can help you organize the information and then identify what the variable represents. So let's look at example 2. So Mark scores 17 points for the home team in a basketball game. His teammates as a group scored the rest of the points. So we have to write an equation to represent the situation. So we know a certain number of Mark's points, right? They gave us his points, plus his teammates' points will give us the total points in the game. All right. So 17, we know. We're not sure what the teammates' points are, so that's going to be our unknown. That's going to be our variable, and they wanted us to use P as the variable. And our total points, I can get that from right here. So they're on the home team, and so they scored a total of 46 points. So what does the variable represent? The variable represents the number of points his teammates scored as a group. All right, so let's take that idea and let's solve this. So the sum of a number, f, and 9 is equal to 38. The sum of a number and 9. So some number plus 9 is going to be equal to 38. So our variable in this case would be the unknown number that we're adding with 9. So we can write x plus 9 is 38. Okay. So the sum of a number and 9 is equal to 38. Number 6, the product of 17 and a number. So again, we have 17 times, because it says the product, and a number, call this one n, is 102. Oh, let me go back and fix number 5. They said to use f. F and 9 is 38. All right, so 17 and 9, the product of 17 and 9, that means multiply, is 102. So just put that together, and that would be our equation. All right, number 7. Craig is C years old. His 12-year-old friend Caitlin is a half year younger than Craig. All right, well, if we take Craig's age, minus half a year will equal Caitlin. Okay. So Craig's age minus the half a year, because she's half a year younger than Craig, would equal 12. Number 8, Kim rented skates for 8 hours. The rental fee was $2.50 per hour. She paid a total of $20. All right. So total, we know it's $2.50 times number of hours. Okay. And they want us to use H for hours. So for every hour she skates, she's going to have to pay $2.50. So that's going to be $2.50 times H equals $20. All right, let's move on. All right, so write an equation and checking solutions. So we know we can substitute a given value for the variable in a real world equation to check if the value makes sense for the situation. So let's look at example 3. Sarah used a gift card to buy $47 worth of food. She has $18 left on her gift card. Write an equation to represent this situation. Use it to determine whether Sarah had $65 or $59 on the gift card before buying. So what does that look like as an equation based on the situation? Well, we have a certain amount of money on the card, right? Then she goes and spends $47. So that's the amount of money spent. And that's going to give us the amount left on the card. So we're going to rewrite the equation with variables and the numbers now. So the amount on the card, that's what we have to find out. So that's the unknown, X, minus 47. They told us she spent $47 worth of food, and they told us that there was $18 left on the card. All right, well, now so we'll write our equation. X minus 47 equals 18. X minus 47 equals 18. Because they want us to see is it 65 or 59. All right, so let's substitute 65 for X. And 65 take away 47 is 18. When we substitute 59 for X, we get 12. So the amount on her card had to be $65. All right, so what if? Suppose Sarah had $12 left on her gift card. How would this change the equation and the final answer? So what they're basically saying here is instead of 18, let's change that to 12. Well, she still spent $47, and we still need to see how much is on the gift card. So the equation would be X minus 47 equals 12. And what would be the answer? Well, let's plug in our numbers. 65 minus 47. And we have to see if it equals 12. Or 59 minus 47. Does that equal 12? Well, again, we already know 65 minus 47 is 18. So that's not correct. 59 take away 47, that's 12. Okay. So in this case, it would be $59. Right. Number 10. On Saturday morning, Owen earned $24 in the morning. By the end of the afternoon, he had earned a total of $62. Write an equation to represent the situation. Tell what the variable represents and determine whether it was $38 or $31 in the afternoon. So what do we have here? We have morning plus the afternoon, and that will equal the total amount earned. Okay, so now let's substitute. In the morning, we know $24. In the afternoon, we're not sure. So I'm just going to say S for the afternoon. Okay, so 24 plus some amount in the afternoon equals 62. All right, so that's our equation. The variable represents the amount earned in the afternoon. All right, so now we have to see, is it 38 or 31? So let's substitute 38 for S, and the other equation would be 24 plus 31. Does that equal 62? Okay, so 38 and 24 is 62. So we know from these that the variable represents just a single number, so this one's probably going to be a false statement. 31 plus 24, 55. And 55 does not equal 62. So the answer is $38. So S equals 38. Made $38 in the afternoon. All right, let's look at page 302. Number 1. All right. So determine whether the given value is a solution of the equation. So we're going to take the 14 and we're going to substitute it for x. So 23 equals 14 minus 9. And does that equal 23? So 23 equals 14 take away 9 is 5. 14 take away 5 does not equal 23, and 5 do not equal each other, so no. Number 2, some number divided by 13 gives me 4. And they want us to substitute 52. So 52 divided by 13, is that 4? Well, let's see. Is 13 times 4 52? Yes. Okay, so 52 divided by 13 is 4, and 4 does equal 4. So 52 is a solution. Number 3, we're going to substitute 5 for k. So we have 25 equals 5 divided by 5. Well, 25, 5 divided by 5 is 1. That's no, right? So k equals 5 is not a solution. Number 4, 2.5 times some number is 45. And we need to multiply by 18. So we're going to substitute 18 for n. And we're going to see if that's equal to 45. So 18 times 2.5 is 45. So 45 does equal 45. So n equal 18 is a solution for the equation. 21 minus h, and we need to see if that equals 15. They want us to substitute 6 for h. So 21 minus 6 equals 15. 21 minus 6, that is 15, because 15 plus 6 is 21. So yes. Okay, number 6. Some number minus 4 is 19. And they want us to substitute 15 for d. So 15 minus 4 equals 19. 15 minus 4 is 11. 11 does not equal 19. So no, it's not a solution. Number 7. Some number minus 9 equals 0. Substitute 9 for w. 9 minus 9 equals 0. Well, 9 minus 9 is 0. So, yes, w equals 9 is a solution for that equation. Number 8, we have 5 times the product of some number and 5 is 31. And they want us to substitute 13 for q. So 5 times 13, and we have to see, does that equal 31? 5 times 13. Well, that's 65. Okay. And we could probably just use logic on that one. We know that any number times 5 has to end in 5 or a 0. So there was no way to get a 1 by multiplying by 5. So no, that's not a correct statement. 65 does not equal 31. All right, number 9. Each floor of a hotel has R rooms. On 8 floors, there are a total of 256 rooms. Write an equation to represent this situation. So the number of rooms, we're not sure. So we're going to say R. But on 8 floors, so number of rooms on each floor, number of floors, okay, will equal the total number of rooms. Okay, so they want us to figure out the number of floors times the number of rooms on each floor, and now give us the total number of rooms. So how many numbers of floors? We have 8. We don't know how many rooms are on each floor, but we do have the total of 256. So our equation is 8 times r equals 256. In exercises 10 through 12, write an equation to represent the situation. So when a number n is divided by 16, the result is 3. When a number n is divided by 16, the result is 3. The sum of 4.5 and a number k is 26 and 2/10. So 4.5 plus some number k is 26.2. Number 12. In the school band, there are 5 trumpet players and F flute players. There are twice as many flute players as there are trumpet players. So we know trumpet players plus 2 times trumpet players actually that's right, plus the flute players sorry, I'm making this more difficult than it needs to be. Okay, so flute players is 2 times trumpet players. Okay. So all we have to do to figure out F is to say F equals 2 times 5. Okay. Number 13. Pedro bought 8 tickets to a basketball game. He paid a total of $208. Determine whether each ticket costs $26 or $28. Okay, number of tickets times cost of the ticket equals total cost. Okay, so substitute what we know from that problem. The number of tickets times the cost of each ticket is the total cost. So he bought 8 tickets. We have to find the cost of the tickets, and we know that the total was 208. All right, so that's our equation. 8c equals 208. We need to find out, is the amount 26 or 28? So 26 times 8, let's see, 48, 16, that's 20. 208 equals 208, right? So we know that 26 is the solution. We can confirm it by just double checking and multiplying by 28. 28 times 8. 8 times 8 is 64. So that amount would be $224. So $208 does not equal 224. All right, 14. The high temperature was 92 degrees Fahrenheit. This was 24 degrees higher than the overnight low temperature. Determine whether the low temperature was 62 degrees or 68 degrees. So we have the low temperature plus 24 degrees Fahrenheit equals the high temperature. Okay, so the low temperature, we're not sure. So let's put T for temperature plus the 24 degrees difference, and that will give us a high of 92. So we have to decide, figure out, is it 62 or 68? So we're going to go 62 plus 24 equals 92, or 68 plus 24. Well, 2 and 4 is 6. 6 and 2 tens is 8 tens. So 86 does not equal 92. So 8 plus 4 is 12. Regroup, 6, 8, 92. All right, so the low temperature was 68 degrees Fahrenheit. Number 15. How can you tell how you can determine whether a number is a solution of an equation? Right, well, basically, if we substitute the value of the solution into the equation, it needs to result in a true statement. All right, and our next to last page, 303, write an equation to solve the problem. Tell what your variable represents. Andy's grandfather, who is 76 years old, is 4 times as old as Andy. Determine whether Andy is 19 or 22 years old. So So we know that the grandfather is 76 years old. And we know that Andy is 4 times so if the grandfather is 76 years old, and that's 4 times as old as Andy, it's also the same as saying 76 divided by 4, or 4 times some number of years equals 76. So we can go 4y equals 76, where y is Andy's age. Okay, and we need to find out, is Andy 19 or 22? So 4 times 19, does that equal 76? Or does 4 times 22 equal 76? 4 times 9 is 36. We would regroup that as 3 tens and 6 ones. 4 times 1 10 is 4 tens plus the 3 regrouped tens. And 76 does equal 76. So I'm going to say Andy is 19 years old. But we should double check. 4 sets of 22. Well, 4 times 2 is 8. 4 times 2 tens is 8. 88 does not equal 76. Right, 17. Me's sleeping bag weighs 8 pounds. Her backpack and sleeping bag together weigh 31 pounds. Determine whether her backpack alone weighs 25 or 23 pounds. So we know that the sleeping bag, I'm going to represent that by SB, plus the backpack, BP, equals 31 pounds. The sleeping bag is 8 pounds. So 8 plus W for weight, 8 plus W is 31. So 8 plus W equals 31. The variable is weight of the backpack. All right, so let's substitute 25 and 31. So 8 plus 25, does that equal 31? Or does 8 plus 23 equal 31? Well, 25 plus 8 is 33. Well, that doesn't equal 31. So 25 is not a solution. 8 plus 23, that is 31. So our solution is 23 pounds. 18. Halfway through a bus route, 23 students have been dropped off and 48 students remain on the bus. Determine whether there were 61 or 71 students on the bus to begin with. So we have students on bus minus those that got off equals students left on the bus. Let me rewrite that here on the scratch piece of paper so it's clearer for number 18. So we have students on the bus at start. We're going to subtract students that got off. And that's going to equal students still on the bus. Okay. All right, so they told us how many students were on the bus. I mean, we have to figure out how many students are on the bus. So maybe we can put S for students minus the amount that got off, which was 23, equals the amount that was left, which is 48. So that's our equation. Some number of students minus 23 that got off gives me 48 left. So what does the S represent? The S is students on bus at the start. Students on bus to begin with. All right, we have to find out, is it 61 or 71? All right, 61 minus 23. Can't take 3 from 1. Let's regroup. That gives me 38. Well, 38 doesn't equal 48, right? So 61 is not right. Let's try 71, take away 23. Again, can't take 3 from 1. Regroup. 11 take away 3 is 8. And 6 take away 2 is 48. So 48 does equal 48. So the solution is 71 students. 19. Write an equation that involves multiplication, contains a variable, and has a solution of 5. Then write another equation that has the same solution and includes the same variable in numbers but uses division. All right. So we know that the solution has to be 5. Okay. So 5 times some number is 25. Well, x would have to be 5, right? 5 times 5 is 25. All right, then write another equation that has the same solution, includes the same variable and numbers. All right, so in this case, we could say 25 divided by some number is 5. And we would say x is 5 again. 25 divided by 5, that's 5. Okay. All right, number 20. How are expressions and equations different? I just want to make sure we write that clearly from the beginning definition. And we said an expression represents a single value. Okay. So equations represent the relationship between two values. I'm going to write two values. And an expression is a single value. Okay. All right, 21. Alan has partially completed a table showing the distances between his town, Greenville, and two other towns. All right, the distance between Hadley and Greenville is 12 and a half miles less than the distance between Parker and Greenville. Write two equations that compare the distance between Hadley and Greenville and the distance between Parker and Greenville. Tell what your variable represents. Okay, so if we do Parker, the town of Parker, Greenville is 12 and a half miles less than the distance between Parker and Greenville. Between Parker and Greenville. So Parker minus 12 and a half would give me Greenville. Would give me Hadley. Okay, so Parker is 29. If we subtract 12 and a half, that'll tell us Hadley. Write two equations that compare the distances between Hadley and Greenville and the distance between Parker and Greenville. Tell what your variable represents. Okay, we could also have 12 and a half plus Hadley will equal 29, or will equal Parker. So again, H So H is the distance between Hadley and Greenville. Alan says the distance from Hadley to Greenville is 16 and a half miles. Is he correct? Well, let's see. Is 12 and a half plus 16 and a half 29. So we know that 16 and a half plus 12 and a half. Add the fraction part first. You get 1. 6 and 2 is 8. Plus 2 is 28. 28 and 1 is 29. So that is correct. So yes, he's right. All right, 22. A problem states that Ursula earns $9 per hour. To write an expression that tells how much money Ursula earns for 8 hours, Joshua wrote 9 divided by some number of hours. Sarah wrote 9 times some number of hours. Whose expression is correct? Well, to figure out how much money somebody earns, you're going to take the number of hours and multiply by the rate that they're paid. So Sarah's would be correct. Okay, Sarah's is because the amount that's earned is found by multiplying rate and the number of hours worked. Okay, you wouldn't divide the amount earned per hour by the number of hours. Okay, so let's say I worked 3 hours and I was getting paid $9 per hour. Well, if I take 9 and divide by my 3 hours, that means I only earned $3. Well, that's less than my rate per hour. So that doesn't make any sense. Okay. All right. And 23. Communicate mathematical ideas. A dog weighs 44 pounds. The dog needs to lose 7 pounds to reach its ideal weight. Michaela wrote the equation some number plus 7 is 44 to represent the situation. Kirk wrote the equation 44 minus some number equals 7. What does the variable represent? Well, that's got to be the amount that the dog loses, right? No, I'm sorry. X would have to be the amount that the dog weighs. So which equation is correct? Okay, so the variable is the weight of the dog. Let's say the new weight of the dog. Okay, which equation is correct? Well, okay, so 44 minus x is 7. And x plus 7 is 44. Well, if we say 44 minus 37, we would get 7 equals 7, right? If we put 37 and added 7, we'd get 44. So they both would work. Okay, so the variable is the new weight of the dog. And so if we say that x is 37, then both equations will work. They're both 37 is a solution of both equations. 44 minus 37 gives me 7. 37 plus 7 will give me 44. So both of those equations, both equations work with that solution. All right, the table shows the ages of Cindy and her dad. Write an equation that relates Cindy's age to her dad's age when Cindy is 18. Tell what the variable represents. All right, so I see here that when she was 2 years old, her dad was 28. So the difference between those two is 26 years. And then 36 take away 10. That's also a difference of 26. Okay, so we know that if we take Cindy's age, 18, and add 26, we would get dad's age. We could also say dad's age minus 26 equals 18. The variable is dad's age. Okay, so whatever dad's age is minus 26 will give us 18. So is 42 a solution to the equation? All right, so I'm going to substitute 42 for D. And does that give me 18? Well, 6 taken from 2, can't do that, so let's regroup. That gives me 16. So no, 42 is not a solution. Explain the meaning of your answer in part B. Well, 42 minus 26 does not equal 18. The dad has to be 44. Because 18 plus 26 is 44. All right, 25. In the school band, there are 4 trumpet players and F flute players. The total number of trumpet and flute players is 12. Are there twice as many flute players as trumpet players? Well, so basically we have trumpet plus flutes is the total in band, total number of band members. So if I add trumpets and the flutes, that's going to give me the total number. So they told me the number of trumpet players. F will represent the flute players, and I know that there's 12. Are there twice as many flute players? Well, F equals 12 minus 4, right? Because the opposite of addition is subtraction. So 12 take away 4, F equals 8. Is 8 twice 4? Yes. So yes. The solution is 8, and 8 is twice as much as 4. Right, 26. Ronald paid $162 for 6 tickets to a basketball game. During the game, he noticed that his friend paid $130 for 5 tickets. The price of each ticket was $26. Was Ronald overcharged? Well, if we go 26 times 5, we get 130. If we do 26 times 6, we get 156. So he should have been charged $156, but he was charged $162. So yes, he was. All right, and finally, 27. Tariq said you can write an equation by setting an expression equal to itself. Would an equation like this be true? Yeah, it would have to be. Yes. So, for instance, if I said 7 plus 4 equals 7 plus 4, well, it has to be true, right? It's the same numbers. It's the same expression. So, yes. Okay. So basically, the expressions would be the same numbers, just on different sides of the equation. Okay. All right. So that's it for our first lesson of Module 11. So I will see you soon, and we'll talk about Module 2.